Hi everyone. So let's continue to solve end of chapter 4 problems. So this is the first problem that we are going to solve for today, which is problem 4-83. So a set of cash flow begins at $50,000 the first year, with an increase each year unit n equals 15 years. And if the interest rate is 7%, what is the present value when the annual increase is $5,000 and when the annual increase is 10%? Okay. So in chapter 4, we've learned about the arithmetic gradient and geometric gradient series. And if the cash flow has a constant amount of change each period, each period, then it is arithmetic gradient series, right? Whereas if the cash flow has a uniform rate instead of uniform amount of change, okay? So if the cash flow has a constant or uniform rate of change, then it is geometric gradient series. Okay. So in this case, the part A is about the arithmetic gradient, and part B is about the geometric gradient series. Okay. So we are solving problem number 4-83. Okay. Okay. So if we draw the cash flow diagram for question A, then it looks like this. This is the present sum. One, two, three, up to n equals 15. So we have 15 here. And the cash flow is a summation of uniform series of $50,000 and the arithmetic gradient series of 5,000, right? So it's like here we have 50,000. The next period is increased by 5,000. So it's going to be 55K. The next period again increased by 50,000. So it's going to be 60K and so on, right? And then finally, we are going to have $50,000 times 5,000 times, I'm sorry, 50,000 plus 5,000 times 14, right? So it's going to be 120K, okay, at the end of the period 15. So this is the A, right? Uniform annual series. And then increased by arithmetic gradient of 5,000. And the next period is A plus 2 times G, right? And at the end of 15th period, it's going to be A plus 14 times G, okay? So obviously, A is 50,000 and G is 5,000, right? And what interest rate we are going to use is 7%. So we are going to use 7% as the interest rate, okay? And this cash flow can be broken into two components, right? One for the annual series, uniform annual series, and another for the arithmetic gradient series. So they are like this. Zero, 1, 2, until 15. 0, 1, 2, until 15 again. So the first one is the uniform annual series of 50,000. Right? And let's say the present sum, equivalent present sum of P1 down here. And second one is the arithmetic gradient starting from the second period, right? Which is 5K. And then next period is 10K. This is G and this is 2G, right? And the last period is 70K, right? That is 14 times G, right? And let's add P sub 2 as the equivalent present sum. Okay. Now, this P value can be computed by summation of P1 and P2, right? So, we're going to get P equals P1 plus P2. P1 is 50,000 times P given A, and 7% over 15 period, right? Plus P2 is equal to arithmetic gradient, which is 5,000 times P given G, again 7% over 15 period. Okay. So let's get these table values. So we are looking at 7%. So you need to look at our text page 610, and P given A over 15 period is 9.108. This is 9.108. What about this? P given G over 15 period is 52.446. This is equal to 52.446. Okay? So, what is this? Okay, so that is $717,630. Okay, so this is the answer for question A. Okay, then how do you answer question B here? What is the present value if the annual increase is 10%? So this is the geometric gradient series, right? So the cash flow diagram for this starting from 0, 1, 2, 3, and so on, up until 15 period, right? So, for the first period, what do we have here? We have $50,000. That is equal to A sub 1, right? And the second period, let's say, is 50K times 1 plus 0.1, right? This is 10%. That is equal to A sub 1 times 1 plus G, right? G is 10%, right? And at the end of period 3, how much do we have here? That's going to be 50K times 1 plus 0.1 to the power 2, which is equal to A sub 1, 1 plus G to the power 2, right? And so on. And then, at the end of period 15, what do we have? We have A sub 1 times 1 plus G to the power n minus 1, which is 14. Okay? So it's going to be something like this. If you connect this, is like, oh, this is not a good diagram. Slightly go upward, okay? Of course, the geometric gradient series is not a linear, okay? This is the nonlinear graph. So we have G equals 10%, and again the interest rate is 7%. So obviously here G is not equal to I, right? So we need to use the formula for this case, which is P equals A sub 1 times 1 minus 1 plus G to the power n times 1 plus I to the power negative n over I minus G. Okay? So we are going to use this formula. So if you use the real value, what do we have here? It's going to be 50,000 times 1 minus 1 plus G is 10%, so 0.1 to the power n, power 15. 1 plus I is 7%, so 0.07 to the power negative 15, right? Over I 0.07 minus G, which is 0.1. So how much is that? That is 856,712. Okay. Okay, so this is the answer for part B. And we've also learned that the difference between the arithmetic and geometric gradients becomes greater. The difference between arithmetic and geometric gradient becomes greater. For longer time period, and for larger rate of changes. Okay? Okay. Then next problem that we are going to solve is problem 4-85. So a set of cash flow begins at $20,000 the first year with a decrease with a decrease each year unit n equals 10 years. If the interest rate is 8%, what is the present value when the annual decrease is $2,000 and if the annual decrease is 10%? So this problem is very similar to the previous one, right? And only the big difference is this problem has a decline gradients, right? So just like the previous case, the part A is about arithmetic gradient series and part B is about geometric gradient series. Is that right? So we are solving problem number 4-85. And let's work on the part A first. So if you draw the cash flow diagram, then it looks like this. 0, 1, 2, 3, up to period 10. Okay. At the end of period 1, it has 20K, right? So, which is equal to A. And then the period 2, how much do we have? It's going to be 18K, right? That is A minus G. G is 2,000, right? At the end of period 3, what do we have? We have 16K. That is A minus 2G, right? And at the end of period 10, what do you have? We're going to have it's 2K. Okay? That is A minus 9G, right? So 20K, 18K, 16K, and so on. And in the end, we have only 2K, 2,000, at the end of period 10. So this cash flow diagram can be broken into two components, right? One for the uniform annual series, another for the arithmetic gradient series. So if you take out 20,000 each period, then you will have uniform series of 20K, right? And let's set the equivalent present sum equal to P sub 1. Okay, let's set this is P, okay? Then we have P sub 1 down here. And the arithmetic gradient series would be, at the end of period 2, we have G. At the end of period 3, we have 2G, and so on. So at the end of period 10, what do we have? We have 9G. Okay? So in this case, G is 2K. $2,000. Okay? And let's add the equivalent present sum equal to P sub 2. Then of course this P can be computed by summation of P1 and P2, right? So P1 plus P2. So how would you get P1? That is 20K times P given A. And what is the interest rate? Is 8%, right? And over 10 periods. And this is negative cash flow. So it's going to be negative 2,000 times P given G, same 8% over 10 periods. Okay? So what is this value? And also, what is this? So we are looking at 8% of interest rate. So from the page number 611 of our text, you can get these two factor values. First, the P given A over 10 periods is 6.7. Is that 6.710? And what about this? P given G, 25.977. Is that right? Okay, then what is this? Okay. Then this is the $82,246. Okay. So this is the answer for part A. Then what about part B? What is the present value if the annual decrease is 10%? So, like I mentioned earlier, here we have a geometric decreasing gradient. So, if you use the equation, what is that? 4 dash. If you look at the equation 4-29 in page number 126, you can see that you can simply replace G with negative g, because we have the decreasing, geometric decreasing gradient. So this is problem 4-85, part B. Equation 4-29. We're going to use negative g instead of g, right? So P equals A1, sorry, this is equation 4-28, right? Actually, A1 times 1 minus 1 minus g, right? Instead of plus g, to the power n, 1 plus I to the negative, to the power negative n, over 1 plus I minus 1, I'm sorry, what did I look at? Over I plus g. Okay. So using the real value, A1 is 20K. One minus G. G is 0.1, right? 10%. To the power n equals 10 times 1 plus I is 0.08, 8%. To the power negative 10, right? Over I is 0.08 plus G, which is 0.1. So we need to get this value. Okay, so how much is that? This is $93,166. That is the answer for part B. Okay. Okay, then next let's solve problem 4-87. Fred is evaluating whether a more efficient motor with a life of 5 years should be installed on an assembly line. Energy saving are estimated at $400 for the first year, and then increasing by 6% annually. If the interest rate is 10%, what is the present value of the energy saving? So the energy savings are estimated $400 for the first year, and then increasing by 6% annually. So this is the case of geometric gradient series. So we are solving problem 4-87, sorry. which is about geometric gradient series. Okay. So if you use the formula, that we've used just ago, right? Which is 4-28, right? Formula 4-28. And we can answer this question very easily. So this is the P equals 400 times P given A, 6% and 10% over 5 periods, right? Here 6% is G and 10% is I, right? This is the same as 400 times 1 minus 1 plus G, which is 0.06 to the power n, which is 5, times 1 plus I, that is 0.1 to the power negative n, negative 5, over I, which is 0.1 minus G, that is 0.06. So how much is this? Okay, so this value is $1,691. So this problem is rather simple. Okay, next, let's solve problem 4-91. The Macintosh company has an employee savings plan that allows every employee to invest up to 5% of his or her annual salary. The money is invested in company common stock, with the company guaranteeing that the annual return will never be less than 8%. Jill was hired at an annual salary of $52,000. She immediately joined the savings plan, investing the full 5% of her salary each year. If Jill's salary increases at an 8% uniform rate, and she continues to invest 5% of it each year, what amount of money is she guaranteed to have at the end of 20 years? So Jill is hired at an annual salary of $52,000, and she immediately joined the savings plan, right? Join the investment plan that investing the full 5%, right, of her salary each year. So let's draw the cash flow diagram for this problem. So we are working on problem number 4-91. Okay. So we have a present sum. At the end of period 1, what do we have? That is A sub 1. So for the first year, the amount of investment is A1. So how'd you get A1? A1 is 5% of how much? $52,000 of her salary, annual salary. So for the first year, the amount of investment is 5% of $52,000. So how much is that? 5% of $52,000 is $2,600, right? $2,600. So A1 should be $2,600. Okay? And we are assuming that her salary increases at an 8%, right? 8% uniform rate. That is, a uniform growth rate per period is 8%. So here, salary increase is 8%. Okay? So this is going to be the value of G, right? That is, the uniform growth rate per period is 8%. And what else? Okay, so basically it's going to be increased by a certain amount, right? Which is 8% increase. And let's say this is the future sum, something like this, okay? And we want to know the future sum, F, at the end of 20 years, right? So we'd like to know how much money she guaranteed to have at the end of 20 years. So we want to know this F value. And the company guaranteed the annual interest rate of 8%, right? So the company guaranteed annual interest rate of 8%. On our employee savings plan, so we can see that I is going to be 8%, which is same as G, right? So here we know that I equals G. So first we can get the present sum of money P at time period 0 by using the geometric gradient present worth vector. because I equals G, we need to use the formula, which is P equals N times A sub 1 over 1 plus I. Is that right? So what is that? P equals N is 20 years, A sub 1, that is $2,600, over 1 plus I. 1 plus I is 8%, so 0.08. So how much is this? That is going to be $48,148. Okay? So now we have this value. P is equal to $48,148. Okay? At the end of period 0. Now, this present sum of money, P, will be converted to an equivalent future sum of money, F, at the end of period 20 years, right? So, F equals $48,148 times F given P, right? And 8% of interest rate over 20 periods, over 20 years. So how much is that? This vector value can be found from our text, page number 611. F given P over 20 periods is 4.661. 4.661. So how much is this? So this value is $225,417.80. Okay? So after 20 years, she will have this amount of money on her savings account. Okay? Okay, and then okay, the next problem that you are going to solve is, what about problem 4-92? The football coach at a Midwestern University was given a 5-year employment contract that paid $225,000 the first year and increased at an 8% uniform rate in each subsequent year. At the end of the first year's football season, the alumni demanded that the coach be fired. The alumni agreed to buy his remaining years on the contract by paying him the equivalent present sum, computed using 12% interest rate. How much will the coach receive? So many of you can see very similar situation in the real world. Okay. So according to this problem description, the football coach was hired with a 5-year contract that pays $225,000 the first year and increased at an 8% uniform rate in each subsequent year. Now let's draw a cash flow diagram for this. So we are working on problem number 4-92. So at the end of the first year, at the end of the first year's football season, the football coach is fired, right? But the alumni agrees to buy his remaining years on the contract by paying him the equivalent present sum, computed with 12% interest. Okay, but before this alumni's decision, let's draw the cash flow for his original contract. Okay, so first year, the 5-year contract pays $225,000 the first year. Okay, so this is going to be A sub 1. And at the end of period 2, his salary will be increased at an 8% uniform rate, right? So 225K times 1.08, right? That is going to be A sub 1 times 1 plus G, right? 1 plus 0.08 becomes 1.08, right? And at the end of period 3, again, his salary will be increased by 8%. So it's going to be 225K times 1.08 to the power 2. That is going to be A sub 1, 1 plus G to the power 2, right? And at the end of year 4 and at the end of year 5, we can compute his salary in the same way. It's going to be A1 times 1 plus G to the power 3. A sub 1, 1 plus g to the power 4, right? And let's add the equivalent present sum, p. Okay. Of course, here, in the second year, this amount came from the initial salary plus 8% of increase, right? So initial salary is 225,000 plus 8% increase. So 8%, 0.08 times the original salary, which is 225,000. Okay. So if you take out 225,000, then what is left? 1 plus 0.08. Is that correct? So which is same as 225k times 1.08. So that's why we have this value, right? Okay. But the problem is the football coach will be fired at the end of the first year's football season, right? And the alumni will buy his remaining years on the contract by paying him the equivalent present sum that is computed 12% interest rate. So our problem has been changed a little bit. So now let's draw the updated cash flow diagram, which would be slightly different from here. Okay? So here we have 0, 1, 2, 3, 4, and 5 years of contract. So he's being fired at the end of the first year's contract. Then what is his second year salary amount? Coach's second year salary. How much is that? There is the initial salary plus 8% increment, which is 225k plus 8% times 225k. Okay, which is 243k. Okay, so at the end of his salary amount, his second year salary amount is 225k times 1.08, which is same as 243k. Okay. And this amount becomes a cash flow amount at period 1 in our new cash flow diagram. Okay, so let's say this is the same as a sub 1 prime. Okay, then the next period, his salary would be increased by 8%, right? So 243K times 1.08 would be his third year salary amount. And his fourth year salary amount would be 243K times 1.08 to the power 2, right? And at the end of period 5, his salary will be increased by, again, 8%. So it's going to be 243K times 1.08 to the power 3. Is that right? So we want to calculate the equivalent present sum. Let's say this is the P prime at the end of period 0. Okay, so we want to get this P prime. Oh, I'm sorry. Actually, we want to get P prime at the end of year 1 instead of at the end of year 0. Okay? So we want to get P prime at the end of the first year. Okay? Because the football coach was fired at the end of the year 1, right, on his contract. So how'd you get this P prime? First of all, we need to collect some relevant information. So we want to find the present sum of money P prime given I is 12% of interest rate, the bottom of our problem description. So, and what is G? G is 8%. So obviously I is not equal to G, right? And here N would be 1 to 5 years, which is 4 periods. Okay? So using the formula, P prime can be computed. So A1 prime, which is 243K, right? So 243K times 1 minus 1 plus G to the power N, 1 plus I to the power negative N over I minus G, right? So using the real value, this is going to be 1 minus 1 plus 0.08 to the power 4 times 1 plus 0.12. I is 12% to the power negative 4 over 0.12 minus 0.08. Okay? So how much is that? So this value is $822,462. Okay. So the football coach will receive this amount of money, $822,000 and $822,462 at the end of the first year's football season. Okay, you're going to receive this amount of money. Okay, so I'm going to stop here for today. And next time, we'll continue to solve the end of chapter 4 problems. Okay? Thank you. See you next time. Bye-bye.